So the first thing we're going to do is define our trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The reason it's important that it says exactly one pair, a parallelogram has one pair of parallel sides, doesn't it? In fact, it has two pairs of parallel sides. So to be a trapezoid, it can only have one pair of parallel sides. So if you take a look at our figure, segment TR is parallel to segment PA. TP is not parallel to RA, so TRAP is a trapezoid. The parallel sides are called the bases. The non-parallel sides are called the legs. In every trapezoid, we should be able to compare some of these angles, or at least do something with them. What can you tell me about angle T and angle P? Very good. They will add up to 180 degrees. Can you tell me why we know that these two have to add up to 180? Not a linear pair? They're same side interior. Likewise, the measure of angle R plus the measure of angle A will add up to 180 degrees because they're also same side interior angles. Questions on our definition of a trapezoid? Can I go to the next page? An isosceles trapezoid. Very similar to an isosceles triangle. First off, it is a trapezoid. And it will be with congruent legs. If we notice, segment AD is congruent to segment BC, which means that ABCD isn't just a trapezoid in this case, it is an isosceles trapezoid. Now, there are a couple things that are true for an isosceles trapezoid. The first one comes from the definition. The legs are congruent. So in our picture, AD is congruent to BC. If it is an isosceles trapezoid, base angles will be congruent. Angle D will be congruent to angle C. And angle A will be congruent to angle B.
I thought they had to add up to 180 though.
A and D have to add up to what? 180. These are same side interior angles. But the pairs of base angles, the two angles that are on the same base in an isosceles trapezoid will be equal. If the trapezoid is not isosceles, I cannot make a relationship between angle D and angle C. This only works because it's what type of trapezoid? Isosceles. Just like the base angles of an isosceles triangle are congruent, the base angles of an isosceles trapezoid are also congruent. The last thing is the diagonals are also congruent, which is why yesterday and in our little coordinate proofs that we did, that it was important that we started out with it being a parallelogram. Because if I draw the diagonals in here from D to B, and I draw the diagonal in from A to C, with it being a trapezoid, isosceles trapezoid, AC will be congruent to BD. So it's not enough to show something is a rectangle just by showing the diagonals are congruent. It had to be a parallelogram first. Questions about our properties of an isosceles trapezoid? Am I good? Can I go forward? A mid-segment of a trapezoid is a segment that connects the midpoints of the legs. If you take a look, MN in this figure is a mid-segment. I can tell it's a mid-segment because M is a midpoint. It cut it into two equal pieces. N is a midpoint because it cut it into two equal pieces. A mid-segment of a trapezoid is equal to half the sum of the two bases, TR plus PA. There are some times when this formula is easy to work with. There are other times where you would be better off saying, if I take 2 times the mid-segment, in other words, if I put 2 mid-segments together, it would be equal to the sum of the two bases. If they give you numbers for TR and PA, this is easy to work with. But if these are all variable expressions, it's easier to work with the second equation. MN, the mid-segment, if I take 2 of these and put it together, it would be equal to TR and PA put together. Okay? Everybody okay with our formulas for mid-segment? So, example 1. They did not mark this as being an isosceles trapezoid. It needs to be marked. If it's not marked, you can't do this particular question. If ABCD is an isosceles trapezoid, A is the same as D, and B is the same as C. So if angle A is 67 degrees, angle D is also what? 67. So that's one of the pieces they're asking me to find. The measure of angle D is 67 degrees. How would I find angle C? Yep, Jordan?
Subtract 67.
Right. These two have to add up to equal 180. Since I've used 67 of them, what's remaining is 113 degrees. So the measure of angle C has to be 113 degrees. Question?
So, and then do you check?
How big would angle B be? It would be 113 degrees as well. In example 2, KLMN is an isosceles trapezoid. They told me NL, the length of one of the diagonals, is 34. How far is it from K to M, the other diagonal? It's also going to be 34, because the diagonals are congruent in an isosceles trapezoid. They told me from K to O is 8. From here to here is 8. And what they're looking for is this value. From M to O. Well, if I've used 8 of it up, how much is left of my 34? 26. This segment has to be 26 units long.
Is there like an explanation for why you just subtracted?
Well, because KO plus OM has to be equal to KM, the segment addition postulate. Okay? So if KO was 8, OM is what I was looking for, KM was 34, what am I going to do to get OM by itself? Subtract 8. Everybody good with example 1 and 2? Example 3 and 4 deal with a mid-segment. They said E and F were midpoints, so I'm going to mark them as being midpoints. And it said this was a trapezoid, so I'm going to mark AD as parallel to BC. It says, in example 3, if AD is 7, so they said this segment is 7 units long, and BC is 3. Find EF. EF is the mid-segment. A mid-segment is equal to half the sum of the two bases, which would be 7 plus 3. So in this case, working with the half is actually pretty easy. EF is equal to 5. If they give you the numeric value for the mid-segment like they do in example 4, they told me that this was 15. They told me AD was 18.2, and they were looking for this value, BC. It is actually easier to take 2 times the mid-segment. It's going to take 2 mid-segments to be equal to the sum of the two bases, 18.2 and the BC. Well, 15 times 2 is 30. And what would I do to get BC by itself? Subtract the 18.2. So BC is equal to 11.8. Questions on example 3 or example 4? Turn the page. Again, they told me that this is a trapezoid and that EF is a midsegment. Especially true when it looks like this. It's way easier to take 2 times the midsegment and set it equal to the sum of the 2 bases than it would be to distribute a half through the sum of the 2 bases. It's just easier to distribute a 2 than it is to distribute the half. Yes? It's asking me to find the value of the variable. I know it doesn't say it, but that's what they're asking. Find x. So I'm going to distribute this 2. 2x plus 4 equals 4x minus 2. Putting my x's together, I have 4 equals 2x minus 2. Adding 2x is equal to 6, which means x is going to be 3. If I plug that back in, 3 plus 2 is what? 5. 4 times 3 is 12. Minus 10 would be 2. 8 plus 2 is 10. Half of 10 is 5. I can see that numerically that worked out. Likewise, for example 6, I'm going to take 2 times 2x plus 11 and set it equal to the sum of the 2 bases. Distributing the 2, 4x plus 22 equals 8x minus 2. Subtract 4x. 22 equals 4x minus 2. Adding 2, 24 equals 4x, which means x is equal to 6. Again, if I wanted to check to see if that made reasonable sense, what could I do with that 6? I could go back here and plug it in. 2 times 6 is 12 plus 11 is 12 plus 11, 23. 8 times 6, 48, minus 12, 30 what? 36. 36 and 10 is 46. Divided by 2 gives me 23. Everybody okay with example 5 and 6? A kite. A kite is a quadrilateral. With two pairs of congruent, consecutive sides. Notice we're not talking about opposite sides, we're talking about consecutive sides. So in my picture, KE and KI are congruent. They're consecutive. ET and TI are consecutive. No sides in a kite will be what?
Parallel.
No parallel sides in a kite. The diagonals of a kite, however, are perpendicular, which is why in that coordinate proof that we did, it was important to show that it was a parallelogram first before we showed it was a rhombus, because the diagonals being perpendicular is not enough to show that something is a rhombus. It has to be a parallelogram as well as having perpendicular diagonals. There is one other thing that will be true in a kite, not both pairs of opposite angles being congruent, but there is one pair. It is the pair that is in between the two sides that are different. Angle KET is going to be congruent to angle KIT. Why do I know for sure that angle K and angle T won't be congruent once I know that these two are? If I know that these two angles are congruent, and I could show you why they are, why do I know for sure that angle K, where this angle is, which I can't call K, I'd have to call it EKI, and where angle T is, why do I know that those have to be different for this to be a kite? Because there's no parallel sides. And if opposite angles were both congruent, it would be a parallelogram. Everybody good? Okay. Example 7, they did not mark which sides were congruent for this to be a kite. So AD and AB have to be marked as being congruent. DC and BC need to be marked as being congruent. And they asked me to find the measure of angle B. If angle D is 110, angle B is also what? 110. Could I find angle A and C? Yes or no? No. I don't know anything about them. I do know that they would add up to a certain value because there's 360 degrees in a quadrilateral, but I don't know, in fact, I know they're not equal, so I don't have enough information to find A or C. In example 8, they again did not mark the congruent sides. You need to make sure that you've marked them. The first thing it asked me to find is the measure of angle KON. KON. How big is KON? It's 90 because the diagonals are perpendicular. The next thing they asked me to find was the length of NK. If I take this triangle and look at it, NK and KL are the same measurement. So if I pull this out and look at it, this is 5, this is 8, and this is what I'm looking for. How would I find it? Say it. Pythagorean theorem. A squared plus B squared equals C squared. The only side that's important is the C side. The C side is across from the 90-degree angle. So this would be 8 squared plus 5 squared equals x squared. 8 squared is 64. 5 squared is 25. So I have 89 is equal to x squared. And what is the opposite of squaring something? Finding its square root. For the sake of argument, let's leave these underneath the radical for now, unless it is a perfect square. If it was the square root of 25, what would you put? 5. But if it's not a perfect square, let's leave them alone. We're going to talk about how we can simplify them. Some of them can be simplified, some of them can't. But for now, let's leave them underneath the radical instead of rounding decimals. Questions on 7 or 8? Example 9. Notice this time they gave me angle A and they gave me angle C, and all I know that is that angle D and angle B have to be the same. How am I going to find these? It has to equal 360 degrees. If I've had 42 and 30, I've used up 72 of 360 degrees in my quadrilateral, which means there is a remaining angle measurement of 288 degrees. And what am I going to have to do to that 288? I've got to divide it by 2 because I'm going to split it evenly between these two pieces. So the measure of angle D is 144. Example 10 is nearly like example 8 was. The first thing they're looking for is angle MOL. And what is the measure of angle MOL? It is 90 degrees. And the other thing they're looking for is the length of OM. They're missing this piece. If I separate this triangle out this time, this is 9, this is 15, this is what I'm looking for. This is also a Pythagorean problem. Which side has to be on the C side? The 15. So this will say 9 squared plus x squared equals 15 squared. 9 squared is 81. 15 squared is 225. If I subtract 81 from both sides, I have x squared is equal to 144. And again, the opposite of squaring something would be finding its square root. And what is the square root of 144? 12. So, from O to M is 12 units long. Questions? That is your assignment.